Bright QT. Every student matters.
Hello students, my name is Sanjay Jain. In this lecture we will learn about angles subtended by a chord at a point on the circle or at the center, etc. Right? So when we have got a line and a point, let us say. So if I say this is point C and I make this angle here. This is the angle that I am talking about. This is an angle subtended by this line segment at this point. So if I name this angle theta, then I'll say theta is the angle subtended by line segment AB at point C. Okay, so in case of a circle, let us say this is a center. This is the center of the circle and this is a chord AB. So this chord AB, if I draw this angle here, angle AOB, that is this angle, this is the angle subtended by this chord AB at the center of the circle. Okay, so and this chord AB can subtend an angle at this part also, right, at this point. So this is the angle subtended by chord AB in the minor segment. Similarly, chord AB can subtend an angle in major segment also. So this is the angle subtended by chord AB in the major segment, right? This is one of the angles. So if let us say this is C and I can have C dash also. So AB can subtend an angle at point C dash also. Okay, so a chord can subtend, a specific chord can subtend infinite number of angles at the circle, that is in major segment and minor segment, but it will subtend only one angle at the center, right? If I specify a chord, let us say that in this case chord AB will subtend this angle at the center and it can subtend infinite number of angles in the major segment and also in the minor segment. We will also learn about a relationship between these angles. Okay, so for now, if I ask you, let us say I've got two equal chords and they subtend angle at the center of this circle. Will these be equal angles? What will be the relation between theta and alpha? This is what we are going to study about in this particular lecture. And if we notice the chords and angle subtended at the center of the circle, if I take a bigger chord, the angle subtended will become bigger. So earlier this was this angle for this chord. Now I have taken a bigger chord, so the angle also got bigger. Okay, so what is the largest chord that I can take? I can take the diameter, which is the largest chord. And what will be the angle subtended at the center? The straight angle, right? So let us study about some theorems here. The first one being equal chords of a circle subtend equal angles at the center. So if I take two chords, let us say AB and CD, right, and I take AB equal to CD, equal chords, right, and this is the center O. This is the angle subtended by chord AB at the center, and this angle is the angle subtended by chord CD at the center. Okay, let it be theta, let it be alpha. Okay, now I want you to notice that OA is equal to OB is equal to OC is equal to OD. Can you give me the reason? Because all of these are radii of this circle, hence they are equal. OA is the radius, OB is the radius, right? So these are equal, right? And AB is already equal to CD because it is given in the question. If we consider this theorem, then we are considering two equal chords and we are observing the angles subtended by them at the center, whether they are equal or not. So AB is equal to CD. If I consider in triangles AOB and triangle COD, I can say AB is equal to CD, equal chords, right? OB is equal to OD and OA is equal to OC, because these are radii of the same circle. Okay, so by side congruency criterion, I can say triangle AOB is congruent to triangle COD, right? And I know corresponding parts of congruent triangles are equal. So what can you say about these two angles? This angle theta is opposite AB, this angle alpha is opposite CD. AB and CD are equal, so theta and alpha are corresponding angles. So these are corresponding parts of two congruent triangles, hence these are equal by CPCT in short form. Okay, so I can say two equal chords of a circle subtend equal angles at the center. Okay, so equal chords of a circle subtend equal angles at the center. Now we will see if the vice versa is also true. Let us say there are two chords in a circle and they subtend equal angles at the center, and we need to see whether these are equal or not. So next theorem is, if the angles subtended by the chords of a circle at the center are equal, then the chords are equal. So let us see. This is one chord, this is another chord, and it is given, or it is to be taken, that these angles are equal, this angle and this angle. So theta is equal to alpha, right? Let it be chord AB, let it be chord CD. So in this case it is given that theta is equal to alpha, and we need to see whether these chords are equal or not. So it is also very easy to see, because we know OA, OB, OC and OD, these are radii of the same circle. So these are equal. Hence if I consider these two triangles, this segment is equal to this segment is equal to this segment, and the angle included between these segments are also equal. So by side angle side congruence rule, I can say these two triangles are congruent, and by CPCT I can say AB is equal to CD. So let me write it for you. In triangle AOB and triangle COD, AB, we need to check whether AB is equal to CD or not. So we will consider rest of the segments. OA is equal to OC, OB is equal to OD. Angle included between OA and OB, that is theta, is equal to angle included between OC and OD, that is alpha, right? So by side angle side congruence rule, triangle AOB is congruent to triangle COD. Now by CPCT, what is CPCT? That corresponding parts of congruent triangles are equal. By CPCT I can say AB is equal to CD. So if I've got two different chords which subtend equal angles at the center of a circle, then these chords are equal in length. Okay, all right.